Hi, folks. All right. So now we are on lesson 4. So this is the last lesson of our series. So the lesson is about the sum of an arithmetic series. Oh, okay. So summing the terms of an arithmetic series. So we're trying to come up with formulae that we can use to calculate the sum of an arithmetic series. So look, by the way, all of this, right, was generated, right, through what and mathematics did in his class. So the teacher wanted to deal with him because he was making noise in class and all that. And then the teacher wanted him to add numbers from 1 up to 100, right? So the teacher actually thought that he's going to take time doing that. But to the teacher's surprise, he did that very fast and very quick. And this is the method from 1 up to 100 without using a calculator, by the way. And he was still very, very young. All right. So this is what he did. So remember that if you have your sequence, let's say your first term is A, then your term is going to be A plus D, right? It's going to be the first, it's going to be A plus. Then the fourth term, A plus 2D plus D, which is A plus 3D. Continue up to the minus 1D. So this is a general sequence, a general arithmetic sequence, this sequence. So S of n is going to be equals to the first term plus the second term plus the third term, continue up until the term before the term that comes before the last term, and then the last term, right? So I'm going to take the very summation that I have here, and I'm going to reverse the order of the terms. So instead of starting with A, I'm going to start with this last term. And you can see that nothing has changed. You only reverse the order of your numbers. That's all. Then now, if this is equation 1 and that is equation 2, you're going to add sum the corresponding terms in equation 1 and equation 2. So S of n plus S of n is 2S of n. Folks, please pay attention. A plus A, right, is 2A, and then n minus D, n minus D. And then notice that here, the second term and the second term here, A plus A is still 2D. And then if I have n minus 2D here, the negative 2D plus D will give me negative 1D. So what is happening here? When you add all these terms, you're basically getting the same thing over and over again. You're getting 2A plus n minus 1D plus 2A plus n minus 1D, blah, 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 2A plus n minus 1 times D. Now remember, how many terms do we have? We have n number of terms. So you can simplify that by saying 2S of n is equals to n times 2A plus n minus 1D, right? And then if you divide both sides by 2, if I divide both sides by 2, therefore S of n is going to be equals to n minus 2, 2A plus n minus 1D. And then note that the last term, we said the last term was A plus n minus 1D. So if we take that, and instead of writing it like that, and we substitute and we write L. So it means I'm not, instead of writing 2A, I'm going to write A plus n minus 1D. So you can see that here I have L. So we have two formulae now, 1 and 2. So you're going to use this one if you're given the last term, right, of your series, and then if you're not, then you can basically use the first one, right? In most cases, get the last term, but if you do, then you are going to use the second one. Please pause the video and try this on your own, right? Try and deduce these two formulae on your own, because this is very, very important, right, for you to know, because it's examinable. Arithmetic series. So for an arithmetic sequence 5, 8, 11, 14, determine the sum of the first 30 terms. Remember that we said if we summing 30 terms, we'll write that as S of 30. We already have a formula to calculate that. So the number of terms is 30. And then first term is 5, right? What's the common difference? 3. So the common difference is 3. And then if you work on that, you'll get 1,455. Then the number of terms that must be added for a sum total of 44. So now you're given S of n as being 44. So now you're trying to solve for n. Okay? So n over 2 times 5 plus n minus 1, 3 equals to 44. And you simplify that. If you simplify that, you should get 3n squared plus 7n minus 808 equals to 0. Then you can factorize that. Remember, if you can't factorize that using this method, you can always use your quadratic formula. So you can just say n equals to negative times a sharp. So if you use that, you'll still get n is 16, or n equals to negative 55 over 3. This one is invalid, because remember, n is the number of terms. You can't have negative 55 over 3 terms. That doesn't make sense. So your answer should be a natural number. So we have 16 terms that must be added. Okay, so for an arithmetic series 7 plus 11 plus 15 up to 151, notice here that you are given your last term, 151. So determine the number of terms. So how to determine the number of terms? The first thing that you need to do is to find the general formula, right? The general formula of what you are given here. So n minus 1 is 7, n minus 1. Then what's the common difference? The common difference is 4, right? And so if you simplify that, oh, by the way, your T of n is equals to 7 plus 4 times n is 4n, 4 times negative 4 is negative 4. And then if you simplify that, you should get 4n equals to 148. And then divide both sides by 4, n is equals to 37. Hence, there are 37 terms in the series. Now, to calculate the sum of all the terms, we now know that we have 37 terms. So you use over 2a plus l. N, we have 37 terms. Then the first term is 7, and the last term is 151. All right, so now it's time for you to work. Please pause the video, try these 4 questions on your own, and then we'll look at solutions when you're done. Hello, folks. All right, I hope you're able to try these 4 questions. Now let's look at solutions together. Okay, so calculate the sum of the first 18 terms of the sequence, right? So this is very straightforward. You just have to use your formula. And if you use your formula, you should get the answer. And because you're not given the last term, the formula that you're going to use for this one is 1D. All right. So notice that because here, then the common difference I'll multiply by 6. All right. Sharp. So that is going to give you your answers there. Right, then for number 2, determine how many terms of the sequence must be added to make a sum total of 510. So in this case, you are given S of n. S of n is 510. So you're trying to solve for n, right? So you need to simplify, and then after you simplify, remember again, I said, if you get to this step and you don't know how to factorize, yeah, you can always plus 37, 1 times 340 times 1, sharp. That should give you n equals to 17 or n equals to 20. Hence, summing either 17 or 20 terms will result in a total of 510. Okay. Now for a series 4 plus 9 plus 14 up to 99. So now notice that the last term is given. Determine the number of terms. Right. Now because in this case, we don't know whether or not this is an arithmetic or a drug series. So just check whether you have a common difference. So 4, 2, that's 5, 5 sharp. So it's an arithmetic series. So the first thing is to try and find your general, your nth term, right? So nth term, remember, as 1d. Then, so your first term is 5. Now, Tn is given as 99. N equals to 20. Now, the sum of the terms is this formula because we have our last term is this one. So, sum of 20, S of 20 equals to 20 over 2. First term is 4 and the last term is 99. And that should give you your answer. Charged per annum with an annual increase of 4,500. Determine the employee's salary in the 6th year. So the salary in the 6th year is going to be the starting salary plus 5 times your annual increase. Yeah. Now determine the total earning after 10 years. So after 10 years, sorry. So you're going to take the sum for 10 years, which is equal to 10 over 2, 2 times the first salary is that it's 90,000 plus your common difference, remember, is 4.5 because you're increasing each time by 4.5, right? And then that should give your answer. So it means if I were to write this as a series, it's 90. Third one has 4, 5 times 2 sharp. So it's like that. So you can see that it's actually please like, share, and subscribe on my YouTube channel, Siyabulela Mukebe, and then make sure that you're going to continue watching these videos. And thank you so much again. Dango.